Alright, let's try this again. Alright. You should be recording. Okay, I don't think we're going to have trouble this time around. Alright, so, if you want to go over the test, we can do that real fast. What questions do you all have?
Yes.
Yeah, Linda, you have so many with that 98, right?
One.
Number one, part one?
Yes, I'm quite frustrated there.
Can I get my
Yes, it did actually. I'm sorry.
Yeah, that's no big deal.
Where is it? There it is. Okay. Number one, part one here. Okay. Going over that one quickly. It factors to.
Oh my god, so good.
Walk over
Did you now see what you did wrong?
Grab mine.
You factored it
It
in.
was -3, -2, right?
Minus 3, minus 2, not
Yeah, you
plus
did
3,
that.
minus 2.
I
Okay.
grab Robin's too.
Yeah.
Oh, you're not fun, Robin. You got 2 points better than me.
Okay. But that was,
You got
that was it,
76.
basically. Any questions there?
This was wrong.
Yeah, it was the other
Get
one.
number one.
C. Yeah.
Hey,
I threw that one on there as a red
there,
mark.
I bet.
oh, come on.
I was
wrong.
needlessly cruel about
Yeah,
that.
that's what I got mine also.
I started with
Yep. I saw that. I was like, oh, he's going to keep it going. Yeah, but people did. I mean, I was very pleased with these. People did very well.
We go to number 3 on the multiple choice.
Number 3 of the choice. Sweetly.
Did you get that right?
So, number 3, part 1. Is that what you're asking for?
Yes.
Okay. How does that look out to be? We've got, okay, 5x minus 7 over x squared times x minus 2 squared. This is going to divvy up into, remember, it's already factored in the bottom, but both of those are repeating linear factors. So every time it repeats, it gets another fraction. So we're going to have 4 fractions here. A over x plus b over x squared, that takes care of the x's, plus c over x minus 2 plus d over x minus 2 squared. And that's how it gets divvied up. Okay? Make sense? Alright. But that's how it happens that way. Okay? Yeah, I thought it was particularly interesting because some people got.
So even if it's not a factor of the equation, you still have to write another fraction for
Yep.
the under. Okay.
Yep. So I saw a lot of people got 2 correct and didn't get 3 right, or got 3 correct and didn't get 2 right, and it's really basically the same question. Okay. Keep that in mind. Any questions? All right. Good. Okay, but yeah, like most people had no trouble. Okay. We're going to go ahead and move on because we got a lot to cover today, or at least I should say a lot. Actually, in all my previous classes today, we haven't done really as much work at all as we should have. Part of that's my fault. Part of that's just too. It's just that this stuff is pretty easy, so people pick up on it, and then we get sidetracked with other questions like giant eagles and things like that.
That's a good question.
But what we're going to go ahead and talk about today, then I'm just going to redo all my notes, make them nicer, okay, is we're going to look at the equations of a circle again. Okay, and kind of go over a few of the homework problems from last night to make sure we got it, and then look at kind of an extreme case that will come up with these circles. Okay, so the thing to remember is the equation of a circle. Okay, basically the equation is x minus h squared plus y minus k squared equals r squared. Okay, and then the various pieces here are that h and k, whatever numbers those are, that's going to be the origin or center of the circle. Okay, and then r, okay, is the circle's radius. Okay. Any questions about that? It's pretty straightforward, right? All right. you typically get two styles of questions involving this. Okay? The first style is one where you're given the origin and you're given the radius, and you're asked to write that into the equation of the circle. Okay? So the first two examples of that for homework, okay, last night, we'll do two of them. The first one was number 1, which said that the center was the origin of the graph. So the circle's center. Okay? And that the radius was root 18. Okay? So from that, what would be the equation of the circle? Anyone want to tell me?
What do you want?
No. It's what? Okay, so
Is
circles.
it 1 over? Is it 1 over the root of 18?
R is 18.
R is 18, so basically, or R squared is 18, so that part we've got.
And then is the 0, 0 the other thing?
So it's 0, 0, so how would I write that into my equation?
X minus 0.
X minus 0 squared plus y minus 0 squared. And as you just got it, it's really just x squared plus y squared equals 18. That's the equation of my circle. Okay? Any questions there? Okay, what's your question? Are you just nodding your head?
How'd you get to that?
How did I get to that? Well, the equation of my circle is x minus 8 squared plus y minus k squared equals r squared. Okay, that's the equation. H and k, wherever they are up here, that's just the coordinates of my circle's center.
Oh, and the graph's origin is 0. Okay, got
So-
it.
Okay, and so basically h was 0 and k was 0. By the way, this is probably one of the easier things to do. You just take whatever these numbers are, and you flip their signs, that gives you the coordinates of the center, the circle center, okay? So if that was like minus 3 plus 5 and up here, this would be 3 and negative 5 down there, okay? We'll see that back in the next problem, but that's how it goes, okay? Any questions there? Okay, this part of circles is pretty easy, okay? Okay, so that's our first example of this type. Now, it's not always so clear-cut. We looked at number 4 from the homework, okay? We're told that the circle's center is at, what was that? 6, negative 3. And instead of being given a radius, we're told that one point on the circle's circumference is minus 2, 4. Okay? So, what we have to do from here is again reconstruct the circle. So the first part's easy, okay? Using my origin point, or my circle's center as 6 minus 3, what would I have for the x plus h, or x minus h squared, y minus k squared thing? It's going to be what? X minus 6 squared plus y plus 3 squared. Okay? Again, just took those numbers, fed them in here, but switched their signs when I did so. That's all there is to that part. So that was easy. Okay? Now the hard part, though, in this case, is going to be figuring out the radius. Why? How am I going to give the radius?
They give you.
Okay, so you're on the right track. I've been given a point on the circle, okay, and I know where the circle center is, so from that I can figure out the radius. And remember, the radius is just the length from the circle's center to the circle's edge, okay? Yes, Lou?
We use Pythagorean theorem.
We'll actually it's the distance formula, which is just the Pythagorean theorem. That's what we're going to use here. Is that your question, or?
Yeah.
Well, I was gonna say, since it's on the circle, couldn't you just use the y value? Because it'd be the distance.
Not quite, because it may not be straight up or down. It could be at an angle, okay? And in fact, if you look here, if these were to line up, any of these numbers were the same, then yes, we could just look at it that way. But in this case here, they don't line up. So it's like a circle. So if I were to draw the circle, the point I have might be like somewhere over here, and so I'm not pointing directly up at it, I'm pointing over to the side, okay? That's all right. We have a way to do it, and as little Roy Boy pointed out, we can actually just use the Pythagorean theorem, basically the distance formula. So as a reminder, the distance formula is basically distance is equal to the square root of the difference in x's squared plus the difference in y's squared, okay? So here the distance for us is going to be the radius. So my radius is going to be equal to the square root of 6 minus 2 squared plus minus 3 minus 4 squared, okay? Which if we work that out, gives us 64 plus 49, which gives us root 113. So the radius is going to be 113, root 113, excuse me. So up here in my equation, what's it going to be? It's going to be, is it going to be root 113 or?
It's going to be 13, or 113.
Just 113, because we're going to square it, remember. Okay? So right here, my full equation then would be this right here. Okay? Any questions about that? How that worked? Nope? All good? All good. Okay. Excellent. Now, I had this question earlier in class, which was, how would I graph a circle like this on a calculator? Okay? And it turns out what you'll want to do is, there's a way we can graph it directly using the calculator that we'll go over later when we study parametric equations. Okay? But for now, if I have something like this right here and I want to graph it normally on the calculator, all I do is I solve for y, okay? Basically, write this where y equals everything else. So doing that right here, okay, I'm just going to say for the calculator, okay, we'll get all our x's on the opposite side. So we'll have y plus 3 squared is equal to 113 minus x minus 6 squared, okay? We take the square root of both sides, okay? And then it's actually plus or minus too, you don't want to forget that. Then subtract 3 from both sides. So in the calculator, I would enter as my graph y equals plus or minus the square root of 113 minus x minus 6 squared, and on the outside of that, I have a minus 3. So if I brought up my calculator, hey, move it, okay, and enter this in, okay, whoa. Okay, so here are all these old graphs. If I enter this thing in, I would have to do it in 2 different levels because it's plus or minus. So my first graph, I would do the square root, okay, of 113 minus x minus 6 squared minus 3, okay? And then same thing with the negatives. Negative the square root of 113 minus parentheses x minus 6 close parentheses squared, okay? Close parentheses again, minus 3. And if I graph this, I'll get a circle. Oh, it's a big circle. Okay? If you notice though, I'm starting to get the circle here. That's great. The thing is, the calculator has trouble connecting the dots fully on a circle. One of the reasons why, and sometimes it doesn't look circular, it looks more oval shaped. One of the reasons why is because the x and the y axis on the calculator aren't necessarily the same size, or rather I should say, the tick marks aren't evenly spaced. To fix that, if I go into zoom and hit square, that'll fix that up. And so now it looks a bit more like a circle, or it looks a little bit circular. If I zoomed out more, I would get it so that this thing would link up. So if I did zoom out just once. Okay. Okay. Still doesn't want to behave or connect up. But I get that's how you graph a circle. Okay. Any questions there? Everyone good? Alright. Reset my calculator standard. So that's the picture. Big circle. Alright. Okay. If that's all good. Now, that's oftentimes one half of the thing you'll have to do with circles is just writing the equation of a circle. The other thing you often will do is have an equation of a circle and go from there to find bits of information out. Like maybe necessarily a point on the circle, or to check to see if the point given is a point on the circle. Or to see where the circle crosses the x-axis and the y-axis, okay? Or just finding the origin and the radius, okay? Which can be a task, okay? So 7 through 12 last night on the homework was when you have a given equation of a circle, just identifying what the pieces are. That should be fairly easy, okay? So if I said, for example, if I had x plus 2 squared plus y minus 7 squared equals 16, from that I should be able to tell you quite quickly that the circle's center was -2, 7, and that the radius was 4, okay? Easy, right? Well, oftentimes circles aren't written this way. Oftentimes circles are written where they're all basically expanded out, and so they look a lot different. So in this example here, we're going to go from the equation to finding the circle's center and radius. Okay? Alright, so oftentimes you'll see a circle written like this example problem here. My example would be 4x squared plus 4y squared, okay, plus 12x minus 24y plus 41 equals 0. A lot of times, this is what you see instead, okay? And in fact, it's from equations like this where we might, and where this could, for example, may not even be a circle. It could be an ellipse, it could be a parabola, it could be a hyperbola. And it's, properties of this, as I start to clean it up, that will help me decide which shape it is, okay? And so it's being able to figure out, okay, what's going on here that helps us be able to figure this out, okay? So we're going to start with something like this right here. The very first step we're going to do, whoops, no, go away, shoot. Okay, so step one, basically, is separate variables . Okay, and remove everything that's not x or y to the other side of the equation. Okay? So, basically I'm going to group my x's together and my y's together first. So that will give me 4x squared plus 12x, okay, plus 4y squared minus 24y. And then I'm going to get everything else on the other side of the equation. So I'll have a minus 41 on that side there. Okay, everyone see what I did? Didn't do anything, just reorganized everything basically. Okay, that should be my first step. Okay, my second step, okay, is basically divide the coefficients of x and y, or x squared and y squared, from the equation. Okay? Now, this is actually an important step, because this will tell me if I'm dealing with a circle or if I'm dealing with an ellipse instead. Okay? For circles, alright, the coefficients of x squared and y squared must be the same for circles. If they're not the same, what do you think I'll have instead what's called an ellipse, okay? So those have to be the same for circles. They are in this case, so I'm going to divide them away. So it will be 4x, whoops, I don't want to do it with that color. So we're going to have 4x squared plus 12x, all that divided by 4, plus 4y squared minus 24y, also all divided by 4. It's equal to minus 41 over 4, okay? We're going to go ahead and do that. So then this will clean up to be x squared plus 3x plus y squared minus 6y equals negative 41 fourths. Any problems there? All right.
Will they always be like that, or will that be one of the problems in the future?
Oh, where they're not equal?
Yeah.
Yeah, actually that will be a problem in the future. And as I've said before, they have to be the same in order for it to be a circle. If they're different, and we'll see somewhere they're different, you actually have a different shape. Okay. For example, if like that was a 3x squared and a 4y squared, I would have an ellipse instead. Okay. So on and so forth. Yes, Darby.
Does the coefficient of like the x correlate to like how, or
For an ellipse, yes. For a circle, no.
like how it's stretched is?
Yeah.
So
So-
that coefficient like before the x and before the y
Yep.
determines like width and height.
Yeah, if this were an ellipse, that would absolutely be the case. It would basically be how far in the x direction it's stretched and how far in the y direction it's stretched. For a circle, they're not stretched in another direction, which is another reason why they have to be the same. Okay? Because we're saying it can't be stretched in favor of y and it can't be stretched in favor of x. Because if they were, then it wouldn't be circular, it'd be some other shape. Okay? Alright, so that's what we get right there. Now, step 3. Okay? We're going to complete the square on x and y. Okay? So, if you remember, back in like November or October, when we last saw it, we did completing the square for a quadratic equation. And I said, don't forget how to complete the square, it's going to come back. And now it's come back. We got to do completing the square here. Yes, Jake? Yeah, sure. Okay. Alright, but that's okay, it's not that hard to do. Okay? All you have to do to complete the square is you look at the singular term, so the 3x squared here, and you're going to add half of its coefficient squared to both sides of the equation. And then do the same thing for the singular term for y. Add half of negative 6 to both sides of the equation. So, we're going to have x squared plus 3x plus 3 halves, half of x squared, the 3 in front of x squared, okay, plus y squared minus 6y plus minus 3 squared, okay, is equal to negative 41 fourths plus 3 halves squared plus minus 3 squared. Again, have to add them on that side of the equation because number 1 rule of algebra, I can do whatever I want as long as I do it to both sides of the equation. Add these over here, so I have to add them over there as well. Keep everything balanced. Okay? Any questions so far? Okay, good. Now it's just a matter of doing what the completing the square does. Okay? When you complete the square, that allows you to basically factor these things down. So this then would factor down to be x plus 3 halves squared. This one right here factors down to be y minus 3 squared. Okay? And now it's just a matter of cleaning this up here. Okay? The other side of the equation, it will clean up to be minus 41 over 4. 3/2 squared would be 9/4. Okay? And then minus 3 squared would be 9, which converted into fourths is 36 over 4. And if I add all that up, I get 4/4 or 1. Okay? Which means then, hey, I got all my pieces now. My circle's origin is now, which is what we were after in the first place, it's minus 3/2, positive 3, and my radius is 1. Okay? Any questions about that? That's about as hard as circles get, by the way. Okay? Other types of problems aren't so bad. So for example, you might get one type of problem where it's like, find the x and y intercepts. Well, to find the x-intercepts, I just make y0. And to find the y-intercepts, I just make x0. And then just solve for the other variable. That's easy, right? Shouldn't be too difficult. Okay. Another one might be show that this point's on the circumference of the circle. Well, you just plug the point in and see if it gives you the same thing on both sides. If you do, then you get, you know it works. Okay. If you don't, you know it doesn't work. Okay. So those two things are easy. All right. Any questions about this right here? We're about out of time for class. So. All right. Tomorrow we'll move ahead. We'll talk about parabolas as conic sections. Okay. All right, everybody. Oh, and don't forget quiz on Cramer's rule. I posted some notes about Cramer's rule on the canvas for the homework tonight. So.